Welcome to the Chapter 7, Section 1 podcast. And Chapter 7 is on Newton's third law, the law of action and reaction. And the Newton's third law is, for every force, there is an equal and opposite force. And you may have heard this in popular culture. You might have heard people say the phrase, for every action, there is a reaction. And we're going to kind of see where that phrase came from. So, a force is always part of a mutual action that involves another force. In other words, they're in pairs. So, a force, as we know, is a push or a pull. And when you push on the wall is also pushing on you. It's pushing back on you. And the action we're going to call is an interaction, which is between two things. Action between one thing and another thing. So if the hammer exerts a force on the nail and drives it into the board, so there must be a force exerted on the hammer to halt it in the process. Otherwise, the hammer would keep on going. And we know that for the hammer to stop, there has to be a force on it. So Newton reasoned that while the hammer exerts a force on the nail has to exert a force back on the hammer in order for it to stop. So in an interaction, there's pairs of forces. One acting on the nail, and in this case, one acting on the hammer. I love this picture because it shows what I'm talking about. When you push on a wall, the wall pushes back on you. Look at this hand; it's pushing on a pane of glass, and the glass is pushing back on the hand. And the reason why you can tell that is because the hand's deformed. You can see how here you can see the hand getting squished here, and at the fingertips, the hand gets squished there also. So there must be a force back on the hand to cause it to flatten out like that. Does a stick of dynamite contain force? No. The force is not something an object has. It's the interaction between one object and another. What the dynamite has is what we call energy. So why do forces always occur in pairs? A force is always part of a mutual action that involves another force.